Here, the job pitch in one of two conditions. One was an audio recording of the candidate's job pitch, and the other one was a transcription. So one was they heard the speech, and the other one was a written condition. And then they had to measure them on three different dimensions: intelligence, competence, and thoughtfulness. And they averaged these to create a single score that measured the job candidate's intellect. And so that's just kind of a basic understanding. So this is what the data looks like in SPSS. And of course, this is a bigger data set than you're working with for this lab, but just keep in mind that most of the time data sets are much bigger than what you're working with currently, and your data set at the end of the semester will be bigger. So condition here is coded as 1 or 0. So again, I'm toggling down here. This is my data view. This is all my data. If I want to see what these 0s and 1s means for condition, I go here, I go to values, and see these 3 little dots here. I click that, and it can tell me. Then I'm going to quickly run the analysis. I'm going to go up to Analyze, Compare Means. This is a between subjects because they were randomly assigned to either the audio condition or the written condition. So it's an independent samples t-test because the samples are independent of each other. It's a between subjects design. My grouping variable is my condition. And the variable that I'm going to run the analysis on is recruiter's rating, and here of intellect. And that's my test variable. Now it wants me to define these things, define my groups. So I'm going to have group 1 was a 0, and then I'm going to click OK. Here it spits out my statistics. So again, here's that those descriptive statistics. And when you're looking at this table, you can see here's the differences between the different conditions. So the transcript condition here, this is the number of participants, the N. This is the mean score, so the mean intellect rating of candidates rating, or recruiter's rating of candidates' intellect. So this is their mean score here, and this is the standard deviation, and this is the standard error of the mean. So the standard deviation is going to tell us the amount of variation in the individual data points from the sample mean, while the standard error of the mean is used to estimate standard deviation in a set of sample means, or how much the sample mean varies from a population mean. This SEM is used to actually calculate the t-statistic that we find down here. All right, so now we're just going to go over this output for the independent samples t-test. And you can see here we have 2 rows, and one says equal variance is assumed, the other says equal variance is not assumed. And this is because the independent measures t-test assumes the homogeneity of variance. And this means that both groups have about the same amount of variance. And so we're just going to go out with the equal variance is assumed row. And if you look over here, we're going to ignore this stuff, and we're going to see this is our t-statistic. This is what we're going to report here. And this next column here is our degrees of freedom. And so the degrees of freedom is calculated as the sum of 2 n's, these 2 n's, 18 plus 21, minus 2 because we have 2 conditions. So you add these 2 up and it equals 39. You subtract 2, 1 for each condition, and you end up with 37. And this is the degrees of freedom that you present in the parentheses after your little t equals. So when you're presenting a t-statistic, you present the t, then you present your degrees of freedom. Here it's 37. Notice I'm going to italicize that t. And that t-statistic was negative 3.526. And then we're going to look here at this next column where it says SIG, and it's telling you again it's a 2-tailed test. So SPSS defaults to a 2-tailed. If you remember the difference, there was a 1-tailed and a 2-tailed test. And we look here and it's 0.001, and that is less than 0.05. So you know there's significance if this value is less than 0.05. And we're going to report that P 0.001. And we're just going to put a little space here to make it look nice. And this is how you report your t-statistic. Now remember, we're looking to see if P is less than 0.05. This is what we're looking for, and 0.001 is clearly less than 0.05. And again, we need to italicize this P because all letters that represent statistical notation need to be italicized. If you look on the lab, there's this document I put together. And so it gives you a little outline or scaffold to help you write up that t-test. And that is what I have here. So we always want our writing in APA format to be double spaced. So it's a significant difference for, we're going to insert the independent variable description here. Now, of course, you're going to do it for the Loftus study that you guys are looking at. I'm going to do it for this study. So a significant difference was found for type of job pitch, whether we did an audio or a written job pitch, was found using, and we're doing an independent measures t-test, and it starts with an I, so we want to use the and not the a. We'll be italicize this t. I'm going to insert that value, and I have it up here at the top. I'm going to negative 3.52. And again, remember, I got that from my table. Your table is going to look similar. We already kind of went over it briefly, but here you're going to where this t column is. Equal variance is assumed. Negative 3.53 is what I should have. And then I'm going to insert the p-value. And again, because SPSS spits out the exact p-value, you can put that in. However, if SPSS reports something like this, if you see in the significance column 0000, you're going to report p is less than 0.001. So now I need to say more specifically what was significant. So more specifically, the recruiter's ratings of candidates' intellect. So I'm going to put that in the dependent variable, the recruiter's ratings for candidates' intellect. For the name the variable, and we'll look at which one was higher. The audio condition was higher. And we're going to put in the mean and the standard deviation here. So the mean is 5.63. And the standard deviation 1.61, 5.63, and again we want to italicize the M and the SD because all of those letters that represent statistical notation need to be italicized. So the recruiter's rating for the candidate's intellect for the audio condition was significantly higher than the, we'll shorten this up here, rating of intellect. And we know the other condition was the written condition for the written condition. Lots of parentheses there. Now we're going to go get that mean and standard deviation. 3.65 and 1.91. 3.65 and 1.91. Again, I'm going to italicize the mean and the standard deviation. These results suggest, so what do we think these suggest? So if I go back and I look at the study's description, it says the authors predicted that a person's speech, vocal tone, cadence, and pitch communicates information about their intellect better than written words. So these results suggest that an individual's speech pattern. So these results suggest that an individual's speech pattern communicates more information about their intellect than written words. We'd want to indent. We don't need this anymore. We want to have it at the top of the page. You could add in that running head and a page number. But this for this lab is really just getting a start and a basis of writing up results. We'll build on this in the next coming labs. So hopefully you get a good foundation for this. Again, remember, this isn't the results that you're writing out. This is for a different study. This is to help you show you how to use that scaffolding that I provided.